Once again, I know it's a lot of repetition, but we're starting off the year and I just want to make sure we're all clear. Let's just review really quick. You all did great last time, but you get 3 engagement points a day, right? What are things that can cause you to lose an engagement point? Someone raise your hand and tell me one. Mason, give me one. Phone. Yep, if you're on your phone at all for any reason, right, once that bell rings, put it away, keep it away. Keep in mind that there's, to me, like that's the very minimum consequence. The much higher consequence of being on your phone is no retakes on the test, which you haven't even seen what my test looks like, so why would you even like test it, right? At least see unit 1 and then decide if you don't want to have to retake. So, Mason, have a smile because I didn't say that. Mary, give us another one.
Setting your classroom on fire on purpose.
I think I would, I guess I'd maybe give you a 0. Y'all probably, I don't even know what happened, but don't do that. Yes. Layla.
Not doing homework during homework time.
Yes, and I'm going to kind of add to that too, right? Not doing homework during notes time, right? Like if we're learning notes, I'm all for using time wisely and getting things done. But our brain, as much as you want it to believe, cannot do 2 slow process thinking things at the same time. We can do fast things at the same time, right? I can walk and breathe and talk at the same time. But to learn something new and be solving problems on your homework, it just doesn't work. There's going to be holes somewhere, okay? Now, what you'll find today is when we do practice problems, I'll come around and check on each of you to make sure we've got it. If I've passed you off, and you're just waiting for me to get the others passed off, that's a great time. Pull out your homework and you can get started on it if you're like, all about using that time wisely. Okay? Thanks, Layla. Have some ideas that. Seth, give us another one.
Talking when you're not supposed to be talking.
Yes, right? So lights are green during notes, meaning one person at a time. So please ask questions, please comment, but we just have to keep it contained. And there will be times, right? Lots of times where it goes orange and yellow because I want you talking with each other. But just help us stay focused and engaged. Good. Have a smile face for that. Ellie. Ella. So close. Okay.
Doing something that's interfering with another person's learning.
Yep. Right. So if you're doing something, talking or drawing, anything that's interrupting their ability to learn is going to cause problems. Good. Have a smile face. Cameron, give us one more.
Doing something that hurts someone else's heart.
Yes. Right. Let's be kind to each other. We can be different. We can have differences of opinion and still be kind. It's not impossible. Grayson. Gavin. I had a G. Gavin.
Trying to not participate, like maybe not talking.
Yes, good one, right? Like if it's time, like you'll see today when we do practice problems, we do a lot of things united as teams, as tables, right? Where I'm like, I'm not going to pass you off till the whole table's ready, right? That means you have to talk to each other to make sure you're all on the same page. And if you're not, then that's going to cause problems, right? Because it's a big part of learning, right, is talking. There's no better way to understand something than to have to explain it to somebody else, okay? Miriam.
Drawing on the desk.
Yeah, please don't do that. Just don't. Good. Have a smiley face. And Henry. Good, right? Like if you're not being engaged, we want to be cognitively here as well as physically present. Okay? Thanks, Henry. Have a smiley face. All right, here we go. So jumping off to what Miriam asked, the reason why we have to understand significant digits and just identifying them is because we're going to do calculations with them, and we need to know how to round. I'm sorry if you were hoping for this, but there's not going to be a question on the AP test that says, how many significant figures does this number have? That is not an AP level question. But when you do math, your answer needs to be rounded to the correct number of sig figs. So that's why we had to learn it, okay? So the rule for addition and subtraction is this, and it's somewhat similar with multiplication, just a slight twist, but it's all about whatever level of accuracy I used needs to be maintained when I do the calculation, okay? When I add these 3 numbers together, this is just the mathematical calculator, this is what it gives you. But this answer has a lot more precision than what I actually measured with. So we have to round to match the least precise answer, okay? Now, when we talk about precision, it's about like what place value does the measurement go to, okay? So this one goes all the way down to the thousandths place. This one, so notice this one goes to 3. This one goes to the hundredth. but this one only goes to the tens. So that means our answer is limited to 1 sig fig after the decimal because we have to go off the least precise value. So our final answer we would report is I get to keep these ones. I'm keeping this one. That's the last digit I keep. Now we do look to see if it should round up based on what followed. So my final answer I'd report would be 25.3. Because that now matches the least precise measurement used in the calculation. Yeah, Cameron, then Sita.
So the first paragraph says the blank.
Oh yeah, sorry, that line fell in a very awkward spot. Least precise. Thank you. When it falls right on that line, it's like invisible to read. I kind of want to just like cut this bar and take it out, and then build more whiteboard up there, and get a Beauty and the Beast ladder to teach on. You know what I'm talking about? Like in the books, wouldn't that be cool? I could like climb up a ladder and we could write everywhere.
You can slide on the floor as like a rail.
Yeah, you know, I could like pull myself across. It'd be so cool. Okay, anyways, teacher dreams.
You could spray paint the background.
Questions on? Oh yeah, Steven, you had something.
Let's say you have like 1 million, 2 million, and then like 3,5,658, and you were adding them together. Would your answer be like 6,005,658, or would it just be 6 million?
It'd just be 6 million.
Okay.
Yeah, so that's, you'll learn pretty quickly how annoying it is to be given data that's not very precise. Because you'll have to round your answer like crazy, and you're like, what the, like this doesn't even seem the same. But because you didn't measure very accurately, you can't all of a sudden have a very accurate answer. So, does that answer your question?
Yeah.
Okay. All right, now for multiplication and division, it's not about the place number, it's about total sig figs. Okay, so here's my calculation, here's what my calculator gave me. I look at each measurement separately. This measurement has how many sig figs?
3.
Okay, so this one has 3, this one has 4 sig figs. This one has 4 sig figs. So I have to round my answer to 3 total sig figs. So not a place value anymore, but just total amount of sig figs. Okay, so right here, so we're limited to 3 sig figs total. So I get to keep the 2, the 3, and that 0. Everything else drops. I do look to see if it's going to round, which it doesn't, because less than 5 would stay. So my final answer is going to be 230 with a decimal point to show that 0 is significant. It wasn't an estimate or a placeholder. Questions on our rules for rounding before I have you try one? Okay, what I'm going to have you do is there's 2 practice problems there at the bottom. Try them out. You can use your calculator to do the math side. That's fine. Once you have an answer, your whole table needs to agree. Once you all agree, turn your lights on to white, and that will let me know you're ready for me to check it off. Any questions? All right, ready, set, calculate. Yes, Marilyn? I don't want, you can't use your phone as a calculator.
I don't have it.
So start bringing a calculator.
I have my calculator in my bag.
Okay. And you don't have a calculator today? Start putting it for this chime in with them, get the math answer, and then you can calculate. The only thing we're doing on our calculator today, so you should really get this. Once you have an answer for A and B, compare with your table. Then, once you all agree, change your lights to white. Question? None of you have a calculator? Where's that left? Oh. Okay, let me see if I can find my box.
Okay, did you guys did? Oh, sorry.
So once everybody's lighted, your table is right, I'll come around and check you off. Ready?
Did you get it?
Yeah, 0.13
Ready?
Yeah, we're ready. I should tell Jamie. I did that homework thing 4 times yesterday. I could not figure it out.
You ready?
Does red make you agree?
Good. I have 2 smiley faces. I guess that one is I don't know if you guys want to just keep pushing it.
I know the first time I got like 7 out of 20.
I got 5 out of 20. Part of it is because I didn't have this. I was used to compete.
I know once I read over the notes.
How are you doing? You all agree? Next time you just tell me. And I know you're ready. Then we'll check it. It's the same as it is, you're good. Okay, you just have 2 smiley faces. Oh, they came unstuck? Yes, but I might need to find something stronger than what I have right now. You can just like, yeah. But I straightened my hair today. And it won't stay straight very long in water.
Oh, shoot.
Look, now the sun's coming out, but it's still pouring.
I have to.
You saw me in the car. I'm 16 this year. I got my driver's license.
January 13th.
Look at that perfect.
So these
You forgot. You saw me in the car. Remember? I'm 16 this year. I don't
Thank you. We're almost there. That was pretty close. Pretty close. All right, we're gonna jump into talking about the structure of an atom. Okay, like I said, the questions you're going to practice on our homework today are not things you're going to see directly on the AP exam. Having a deep understanding of what atoms are and how they're built is fundamental to understanding so many things we're going to talk about this year. Okay, so we just need to make sure it's grounded. One thing that we'll kind of start today as we're jumping into more chemistry-related content. Sig figs are just kind of, I don't know, it is chemistry, it's all science, but it's just numbers. Is as we learn topics in this class, I'll bring it up, but I would encourage you to engage your own brain with making sure as we talk about different things that you look at them from all three sides of what I call the triangle of understanding. If you look at every topic we talk about from all three sides, to me, that's when learning really happens. If you focus too much maybe on one side, then to me that's where you're falling into the trap of just trying to memorize to get through something. But if you can see it full picture, meaning number one, what does it look like with our eyes, right? In terms of an atom, we'll talk about it today, like what can we see with our eyes when it comes to atoms, okay? This one is a little bit more abstract because we're looking at what we can't see, and sometimes that means a made-up picture in our head that's kind of right, but it gives us something to grasp. You have a model in your notes we'll use today that's actually quite wrong when it comes to what an atom looks like. But a real model of an atom is very abstract to have in your head when you're trying to understand these concepts, so it's a good start. So sometimes it's a model we have, sometimes it's a model you're going to make up. Often for me with atoms, it's either visualizing Legos or bouncy balls. And that's how I see atoms, like how atoms, when they react and build, that's what I see, okay? Then the final piece is connecting that to symbolically, what do we write? This comes down to symbols, to numbers, to the math, right? If you find yourself confused by the math, it's often because you're not understanding the why behind it, okay? All right, so as we look into our atom, let's talk about the three main parts, okay? The three main parts to every atom. So every element on the periodic table is a type of atom. Every atom has these three parts. I'd like you to pick a color of highlighter out of your box, whatever color you'd like, okay? And I want you to make a color match here for your brain. So mine's red protons, and so these are colored red. Pick a color of your choosing, highlight it this color, draw an arrow, and then color your plus signs that same color. Does that make sense? Because yours, I can't print in colors, so I'm having you color it. I know it's kind of dark already, but do a rough, just so you know, okay, these positive things are the protons, okay? Like I said, they're positively charged. The name maybe helps, P positive, right, protons. They're located in what is called the nucleus. That's what this blank right here says, is the nucleus of the atom, which is really just the center. Okay, so we call the center of the atom the nucleus, and protons are located in there. They have a mass of approximately 1 AMU, and AMU stands for atomic mass unit, which we'll kind of talk a little bit more later about how it came to be, but you should recognize in science that all units are just made up, right? Somebody once upon decided, hey, this is how long a foot is going to be, and it's going to be this long. It's kind of fun, back in history, it used to be the king's foot size, but then they got sick and tired of like changing dimensions because the king died, right? So they just established something. So an AMU is the same thing. It's just a unit assigned to measure atoms because they're so tiny. Units we're used to, like pounds, ounces, grams, are way too big when it comes to measuring protons. So they needed their own unit, okay? This is the big one. Put a star on this one. This is the key thing about protons to understand, is they are the identity of an element. The number of protons identifies what an element is. Carbon is the only element with 6 protons. If it has 6 protons, it must be carbon. If it's carbon, it must have 6 protons. It is the identifying piece to what makes an atom its identity, okay? Now on that note, simply enough, the way to make new elements is just by adding protons to the elements we already have, and that's in a sense what scientists did. If you look over here really quick on my periodic table to break down the code, all these ones in white writing are synthetic and man-made. So they were created in a lab. I guess not really a lab, more particularly it's called a particle accelerator. Their nicknames are atom smashers. but that's in a sense how these got created is scientists took big elements we already had, shot protons at it, hope it stuck. If it did, I get to name a new element. Simple in word, much more complicated in practice. But okay, that's key thing to recognize. Protons make something what it is. Okay, and then there's a link between protons and the atomic number on the periodic table. So that's why no two elements have the same exact numbers, because that tells you how many protons it has. Okay? All right, grab another highlighter here, and let's do the same thing for neutrons. So draw a line from the word neutrons into your model, or color code it so you can see the match. Neutrons are the other thing in the nucleus. They are neutrally charged, hence their name. They also have a mass of about 1, so them and protons are pretty similar. And then their key thing is really, they just make the atom heavier or lighter. They don't change its identity. They don't really change how it reacts. But you can have a heavier version of oxygen than another. The various variations you can have, so for example, this is carbon, and it has, how many did I put in here? 7 neutrons. So this would be classified as carbon 13, because the 13 is protons plus neutrons, right? So you can have carbon 12 as an isotope, carbon 14 as an isotope. This word isotope just signifies all the different variants of carbon that exist in the world. Yeah?
Theoretically, couldn't you just keep adding like neutrons to an element and they're an atom, just like making it heavier and heavier?
Good question. Yeah, how's my face for that? So theoretically, yes. What happens, and this is the one where neutrons can start causing issues, is when you start disrupting the balance of neutrons to protons too much, the atom doesn't like it and becomes known as radioactive. And they start kicking things out because they're unbalanced. Sadly, we won't actually cover radioactivity in AP Chemistry because it just isn't part of our curriculum and we don't have time for it. We can talk about it in May if anyone's curious, but in a sense, when an isotope is radioactive, it's because it has an off balance of protons to neutrons. So yeah, great question, Cameron. Yeah, Steven.
So, neutrons and the protons are about 1, but are they the exact same weight, or?
No, it's actually pretty interesting. Like, there's this line that like scientists have figured out called the line of stability in terms of the perfect ratio, but it's not a linear line. It like, so if you graph like atomic number versus like, or proton to neutron number, it like is kind of linear in the beginning and then it like goes up like that. So it's kind of like, they know what it is, but it's not always 1-to-1. Did that answer your question? Kinda. Yes, Mary.
So in the bottom of each like little symbol on our like table, it has an atomic mass.
Yeah.
How can they like have that if it's different for different types of that element?
Great question. Can you hold that for like 2 minutes, then we'll answer it? Yeah, we'll lead into that. But I think it'll make more sense once we get there. Marilyn, did you have a question, or is that?
I'll just wait until he's answered Mary's.
Okay, it falls in the same category. Okay, let's talk about electrons, and then we'll talk about that other number on the periodic table. So electrons are negatively charged. Oh, that word got cut off there. They're outside the nucleus. There's a variety of names for where they are, but it's actually empty space. So I just say they're outside the nucleus in empty space. Sometimes they say there's electron shells, there's electron clouds. They're not really rings. Once again, that's where this model's quite wrong. But it gives us a starting visual, and this is easy to draw, right? The other models get quite more complicated. The key thing about electrons are 2 parts. One, they have a mass of about 0.0005 AMU. Can anyone, by raise of hand, give us a comparison then, like a proton to an electron, compare those 2 numbers for us? The proton is 1 and an electron is that. How much smaller is an electron? Gavin.
Yes.
Okay.
An electron would be based on something like 1/10,000 for the mass. Proton is.
Yes, so imagine if you have a proton, to get the same equivalent size of an electron, you'd have to cut that proton up thousands of times. 10,000s of times, right? So that's one way where these models are very flawed. Is if I'm going to draw a proton that size, an electron is technically, like I wouldn't even see it in the picture, right? They're so much smaller. So that's one thing to keep into account. When we talk about the mass of an atom, we often don't even think about the electrons. Because taking an electron in or out of an atom is like me taking a hair off Seth's head, right? Like, it's not really going to change his mass, right? Like, yes, technically did it scientifically, yes. But big picture, they don't change. What they do to an atom, though, is they impact their charge, which really is what we're going to talk about all year, because that determines reactivity. So electrons control the reactivity behavior of things. Why two things will explode and other two things do nothing. It's all about actually their electrons. So that's kind of the job of the electrons, is they control the reactivity of an atom. Okay? All right, so let's look at our two symbols. So we looked at the periodic table already. This right here is an isotope symbol. So often when we're talking about isotopes, we'll write this, but then this is what we see on the periodic table. Okay? All right, so you have some arrows there, so we'll kind of label what each of these numbers mean. Okay? So I didn't label it as an arrow because I thought it was pretty straightforward. But the C is the atomic symbol. Makes sense. Sorry, there's not an arrow for that, so you don't have to fill anything in if you don't want to. Okay? But this one, fill this arrow in. This number down here is the atomic number, but on the periodic table, it's written up top. So it's kind of like this flip-flop thing we did as scientists, who knows why, when we like write it versus how we see it on the table. Okay? But this right here is like the proton number of an atom. It's really easy if you have a periodic table, which you always will, to find the protons, right? If I say, hey, how many protons does aluminum have? Well, you just have to find aluminum, and then you know how many protons it has. 13. Okay? Now, in the symbol, I'll be honest, this number is not always, it's not necessary. Because if it's this, it's always going to be this, and vice versa. So often I won't write them because I'm a lazy scientist sometimes, I guess, or efficient scientist. Okay? And you don't have to either, but if you see it, just know, oh, it's just telling you the proton number. Okay? All right, next number is the atomic mass. Let's go to what Mary brought up here, this number. So let me bring up my color coding here. So this number right here is the atomic mass. The atomic mass is a weighted average of all the isotopes of carbon in the universe. Okay, so this is a weighted average of all, and it's done by their precise mass as well. While this one is purely just protons and neutrons, which gives you pretty much what the mass is, but it's not as precise. Yes, Seth?
How are they able to get those numbers?
Great question. So there's this, you don't need to know the name of the law, but there's this thing that they figured out. Do you guys understand like the difference between like a theory, hypothesis, and a law in science? Have you learned that before? The big thing to recognize is if something is a law, it's not what's just like this is somebody's idea. Like it is backed with truth. If these laws aren't true, our world will fall apart. Like, because it's just, everything is based off these things are true, and we've seen that true over and over again. So what they found with isotopes is really interesting is that in every sample of something, the ratio is always maintained. So let's say water, for example, okay? So if I take some pure water from Utah Lake, well, it's not pure when I take it, but I make it pure, okay? And then I go take some water from, where else do I get water from? Where? Bear Lake, right? Two different places, okay? The ratio of the isotopes of oxygen are always the same. So that percentage base, that's how they know, is that every sample they gather, the breakdown of, 25% of the isotopes are this, 30% is this one, 40% is that one. That ratio is maintained in every sample gathered. Does that make sense, kind of?
Yeah, that makes sense.
Yeah, great question. I'm a smiley face for that. Did I see another hand? Okay, everyone have this arrows filled in? Yeah, Mary.
Wait, so, like, the one on the right, that's just the weighted average, but, like, how did they, like, if the number is different on all the isotopes, how did they, like, get the flat number of just this is how many protons and neutrons it has? Like,
So when you're representing a mass number, the whole number, that's because you're talking about this specific isotope. It's like I'm only looking at carbon 12 in this example. If you're looking at carbon as a whole, there really isn't an answer in terms of how many neutrons it has because, well, sometimes it has 7, sometimes it has 6, sometimes it has 8. And so like the mass number is like I'm looking only at this isotope. So often what is sometimes done, and I'm not saying it's wrong, one thing you'll learn, as I learned as I took chemistry, is sometimes earlier teachers, they weren't lying to you, but sometimes you just like, you have to like change things a little bit because of the level of understanding, right? So sometimes in younger science classes, you may have learned to find neutrons. You look here, round it to a whole number. Anyone familiar with doing this method? If you haven't, just ignore me because I'm going to teach you how you should do it. You'd round this to a whole number and then you'd find the neutrons that way, which is correct in at least the most common isotope you could find it for. But if I'm looking at a specific isotope, then the mass number is going to be more value to us. Does that answer your question?
I think so.
Okay. Miriam.
Do we know why one isotope might be more common than another?
It kind of goes back to that idea of stability of like that line I drew. The more it is on that, whatever the perfect ratio is, are more stable. Because radioactive isotopes, they go through a process of decay and they change. And because they're radioactive. And so then they just don't exist very much because they're always decaying. So does that make sense? Steven, did you have a question?
So if you just have any specific isotope, will the number always be a whole number, except for like the electrons that are?
Yes. Yep. So a mass number, a specific isotope's mass number will always be that whole number. Technically, it's detailed mass because electrons would be in there and stuff like that. But yeah. Yeah. Let's write this out. Go ahead, Marilyn.
So how do you find the number of neutrons in this carbon, for example?
Great question. So you're gonna have to be given the mass number
Okay.
if they want it for a particular isotope. If you're going off the average, then you would round it to a whole number and subtract. But you'll see, and so we'll do a practice problem after this slide, and you'll see that some information must be given. So what we're kind of building up to, everybody, is it's a little bit like a chemistry Sudoku of if I give you a little bit of information about an atom, you should be able to fill in the rest of the missing pieces using the periodic table. Okay? So this is what I said, but let's get it filled in. So mass number is protons plus neutrons. It's not what is on the periodic table, but it should be relatively close to it, right? Good like mental check. If you're doing a problem and you're saying, oh, this has a mass number of 50, but on the periodic table the average is 12, I'd maybe check your math, because that's pretty unlikely to have an isotope so far from the average, okay? All right, everyone okay on this slide? Yeah.
When you say mass number, do you mean atomic mass?
So the mass number is like what's given for an isotope, right?
Oh yeah, okay.
Does that make sense?
Yeah.
I know sometimes these are other words and I'm like, scientists, could we have come up with a better, like, not so confusing definition? But yeah.
What is the blue highlighter saying? Sorry. It's
Atomic mass.
Oh, okay.
Yeah, the atomic mass is the average mass of the element. All right, the other classifications, we have isotopes, which are different elements of the same kind, but different mass number. Ions are when they become charged. So this is just another vocab to be familiar with. If you come across an ion, it just means it's an atom with a charge. Now that charge can be positive or negative, depending on what happened to it, okay? So positive ions are formed when you have less electrons than you do protons. Because think in mind, protons are positive, electrons are negative. If they're the same, it will be neutral. Just like in your life, if you have the same amount of positive things as negative things in your life, you can have a neutral life. If you want a positive life, then you need more positive things than negative things. Now, the words that we use to describe them are kind of weird in how you say them. This word right here, imagine there's a dash, and we're going to say the word ion by itself. So it's called a cation. It's not a cation. even though that's how it looks. It's kind of a way to know someone's never taken chemistry, is because they read this word as cation. But it's a cation. Same thing, a negative one is called an anion, not an anion. Once again, I don't write these things, I just teach them, so don't know why they picked it. But it makes for a fun little picture to remember them, that a cation is positive. Because cats have paws. Get it? Positive? Yes? Okay, thank you. Okay, questions on this before we try a problem together? Alright, so this is what part of your homework's going to look like tonight. I'm going to give you, not very much, but a little information. Your job is to fill in the rest using the periodic table. Don't let me forget, because I don't think, have I given you guys a hard periodic table for like home use yet? Don't let me forget to give that to you, because you're going to need it for this. It'll make it easier. And I have them, I just keep reading past them out. Okay, I'm going to do these three with you. Follow along with me, and then you'll try the next three on your own. Okay? I'm also going to be using different colored markers very strategically to show like where the numbers came from. So if you would also like to highlight to be like, okay, I got this from here, or I'm going to be doing it on purpose, changing my marker colors. Okay? All right, so first one here tells me chlorine 37, right? So from this information, this 37 is the mass number. We label isotopes by their mass. It's similar to like wrestling or like UFC, like they're categorized by their weight. That's how isotopes are too. You categorize them by their mass. Okay? All right, the next thing is because it's chlorine, I can go to the periodic table and I know, or I can find chlorine on there. Its symbol is Cl and its atomic number is 17. I just found Cl on the periodic table. Right there, 17, and it's a 2 for 1 because these two are always the same. Okay, so I found those. All the greens came by looking at the periodic table. Okay? All right. Just going in order, you don't really have to, but I don't know how else to do it. Electrons. What you want to think about with electrons are charge. The charge is going to give you some indication about what's going on with the electrons. In this case, there is no charge. If there was a charge, it would be written on the name. So there'd be like a +2 or minus up here. But if there's no charge, then the charge is, you can write neutral or 0. Okay, so since this is neutral, that must mean if these are positive, right, protons are positive, electrons are negative, what must it mean if it's neutral?
17 electron, right?
They have to be the same. Yep, thanks, Grayson. But only because it's neutral. So don't think, oh, these are always the same, right? It's only because it's neutral. Okay, finally not my electrons, we just did those, my neutrons. So electrons you think about charge, neutrons you think about mass. So I know my mass number is 37. Which one of these doesn't matter when it comes to the mass? Electrons. Electrons are hairs on your head. Don't matter. So we're going to do 37 minus 17, because that's our protons. And that will equal, that's supposed to say neutron there, or neutron. So we have 20 for our neutrons. So mass minus protons equals neutrons. Yeah, Marilyn?
Just wondered, is there any point where there are so many electrons that it sort of does start to matter?
No. Good question though, yeah. Because in the end, like the electrons are always going to be within plus or minus 4 of the proton number, and so they're never going to outweigh the others. But good question. Steven?
Do we need to write the isotope number, the mass number?
Oh yes, thank you. Let's finish that off. So we have all that. On the symbol, we do want to add the mass number. Good catch. Yes, Cameron.
Your iPad's low battery.
It's a
Can we make it? 5%?
Yeah.
Come on, you can make it. Okay. Any other questions? All right, let's try this row together. I'm gonna go a little faster, but please stop me if ever you're like, whoa, where'd that come from? Okay? A common phrase you hear me say is, science is magical, but the numbers shouldn't be. Meaning if it's just like, where'd that 20 come from? Ask something, because there's a reason behind it, okay? All right, AG 107. 107 tells me the mass number. AG tells me it's silver. Knowing that it's silver, I can find it on the periodic table, and it has an atomic number of 47, which is the same here. All right, so knowing that it's silver, I can find proton and atomic number. No charge, so charge is neutral, which means must be the same. Neutrons are related to the mass, so we're going to do 107 minus 47. And we're done. Questions? Yeah, Nathan.
For the charge, could you write 0?
You could write 0 as well. Yeah, good question, Nathan. All right, let's do one more together, and then I'll push you into the pool. So Mg, magnesium, 25, and then since this has a charge, on the name I'm going to carry that charge over here. Find magnesium on the periodic table, and it has 12 protons. I already know its mass number.
Do you just have that memorized?
Yes. I look at the periodic table a lot. It's kind of like, I don't know, like when I'm like an old grandma, I want that to be like my cool grandma trick. It's like my grandkids can like ask me any element and I could be like 62. You know? I don't know. Would that be cool, grandma? I don't know. Anyways, okay, back to this. Now, this one is where it's different. Our charge is positive 2. It was given there. Remember, never assume a charge. Always assume neutral unless told otherwise. Okay, here's how I choose to think about it. Protons are positive. Electrons are negative. If it's positive 2, that means I have 2 more positives than I have negatives, so my electrons must be 10. If it was negative, then you'd have more electrons than you do protons. Questions on how to figure out the charge? And then this would be 25 minus 12, 13. All right. I would like you to try the next 3 rows with your table buddies. Talk to each other about it, help each other about it. When you're ready for me to check, meaning all your answers are the same, change your lights to green. I need to know the order of my lights. Green. When you're all ready to check. And then this is a great time if you finish and maybe you're waiting for your table to finish, you could pull out tonight's homework and start working on that while you're waiting. Okay? No, it's that. Remember that packet I gave you last time? Yeah, just that first one. All right, let me know if you need help. Otherwise, get to work.
Wait, Jamie. Is this the only homework we have? Or is it like...
That and then the safe big quiz if you finish it.
Yes.
Oh, that's right. I was going to get your periodic table before I forget.
This is your copy. This is in your body.
I'll have your own periodic tables. This is your guys' copy to take home of the periodic table. Periodic table binders. Once again, when lights are green, that means everyone at your table is ready to pass it off to me. Oh, you already got some. You need some.
Are you done already?
Technically, there is big pictures. There is actually a big picture. But it does have to. So, yeah, we'll learn about, like, it's the idea of a chart after, as far as I've learned, is an actual, like,
We get the same things.
I think so.
I think I'm
Maybe I get it.
No, I got it.
you don't need to. You guys, I'm hearing that. Well, if not, you can give her time, give her space. When she's ready,
No.
then check together.
You did get it. You did get it.
Yeah.
Yeah. Okay.
Where is Sophie?
Right, I'm saying time, don't rush her. And then when you're ready, how we compare with them.
And then you gotta write it out like this.
I think about like a scale. It's like more negative.
All right, ready? Everyone ready? Or not ready? Did you compare with each other?
I just want that to write.
No, you're good. I just want to make sure if I check one, it's going to be valid for, like, you're all the same. Yes?
I love this game.
These crazy
I'm gonna have to
rainstorms.
walk in that.
15 minutes maybe to stop. Okay, good job, guys. Go ahead and you can work on the homework and give yourself 3 smiley faces.
For framing in the rain, get smiley first.
The math number found something. I think we did.
When your table's ready and all your answers match, change your lights to green.
Wait, is it 1.1?
No, it's just this atomic structure.
Whole package.
Just the first page. Yep. So like each of them have a heading, so it's just whatever heading is assigned. So it's just
So not the back of that one?
the back two. So until there'll always be like a new heading if it's like a new. So if it is only a one-side assignment, I don't know if there'll be anything on the back, but if there is, it would have like a new heading, a new name place. So you know it's like a new assignment.
I'm kind of confused on how to do this because I tried just adding all of them divided by 2, but that didn't work.
That's what we're gonna get to next after I check everybody's off of this. Alright, ready?
But you guys did the first one.
I haven't done it yet.
I've done it.
Wait, did we take this yesterday?
Ready? Alright, I check Mary's, you're on the same.
This is which one?
Good job. Have 3 smileys.
Yeah.
For sig figs, if there's like a number and then just after the decimal a lot of zeros, they be
They
significant.
would all be significant if they're after the decimal. Yeah.
So for these numbers,
Yeah.
it's not molar mass.
Atomic mass. It is also molar mass. They're like the unit just changes, but it's also the molar mass, which we'll learn about next time. So you're not wrong in it.
We had a lot of sections around here.
What?
You better have your little brother with you because if you talk like that.
I don't have one.
The smallest. There's not too many people who can use
I'm not. Looks like water, right? Looks like water.
Salt. AP Chem they are testing like traditional. I don't even know Chinese. That was crazy.
It's weird sometimes when you take a test in your native language and it's like, I don't know this.
Because there's like simplifying traditional. Traditional is more hard. The meaning the same.
My cousin takes Chinese, and I've seen her homework, and I'm just like, oh no. Why? Just have them all do the easier one.
Should we start on homework? Should probably do homework, right? No, we at least gotta get some.
We should go to the Arsenal field. Super cool. I'm so down to go to Yeah, it smells terrible right around.
Anytime, if it's a new, like, separate thing, you'll see, like, a new header.
No, it's gone. It like smells so bad. It smells so bad. It smells so bad. It smells so
Well, it's just like still water. It just smells like it would
I think it's everything but all my ones.
Have a smiley. Sounds beautiful. Okay, set your homework aside. Maybe flip it over. We just have one last little thing that's going to help you finish those problems on your homework. Okay, and then whatever time we have left, you can finish it. Okay, just to clarify some things people